All right, welcome to class. We also want to discuss integration, and the integration type we want to talk about is the indefinite integral. First off, what is integration? Integration is the increase of the power of x by plus 1. Integration is the increase of the power of x by plus 1. That is integration. Second off, what do we need to know? We need to know that there are two types of integrals. First, it's called definite integral. And then next is called indefinite integral. So this is what we have. Now, what do we understand by the word definite integral? A definite integral is simply the kind of integral, or is simply the kind of integration with upper and lower limits. This is the type of integral with upper and lower limit. So look at this. If I have this, let's say here is x raised to the power of n. If I have any number here like this, added to this integral sign, this becomes a definite integral because we know the numbers. It becomes a definite thing. But indefinite integral is simply the integral, or is this type of integration or integral sign without upper and lower limit. Please, this is called upper limit, and this is called lower limit. So for the one who want to do indefinite integral, it doesn't have upper and lower limits. So next thing to note, number 3, remember the definition is number 1, the types of integration is number 2. Number 3 is this: wherever you see 1 over x, if you are integrating that, it becomes in x, or natural log, like this, natural log of x, like this. But I would prefer we use this. So in is natural log of x. So anywhere you see 1 over x, you put in x there. That's what I'm saying. And then the fourth thing you have to note, wherever you start integrating, your final answer, you must add plus c there. Your final answer, you must add plus c there. So with this thing said, let's go ahead to solve some questions. I want to work with general method. General method. So we have the method to work with. So number 1, we want to find the integral of 6x 5 3x 2 minus 8x 3 then plus 10 with respect to x, like this. So this is the first thing we need to do. So how do we go about this? Now, the first thing you have to note is that we are going to separate, because we have all these signs, plus, minus, and plus. We're going to separate each of them with the integral sign, and then we add the x to that, like this. So first, I'm separating this one. I'm having raised to the power of 5 dx plus this one. So bring this integral here. So we have this value, then the x here. Bring this value here, integrate this one. We're having 8x cubed. Always add your dx to that, and then bring this one here. So we are adding x to this. So this is it. This is the first task. Now, the next task is this: separate out the coefficients that is standing with the x. Separate it out. So we have the integral of this one, dx, plus the integral. This is bringing out this one. We have this dx here minus 8 dx here, plus bring out this 10. So this 10, when you bring it out, we are having 1 left here. 1, if you bring this one out, because 1 times 10 is 10. So let's put it like this. So this is what we have. Now let's start integrating. The next thing is to integrate. So if you are integrating, this integral sign and this dx goes away. So I have x raised to the 5 plus 1 here, then 5 plus 1 here, plus this integral and this dx goes away. So I want to integrate now. I have 2 plus 1, then minus the next thing that this one goes away, this dx and this integral sign goes away, and then we have 3 plus 1. So plus here I'm having this 10 here. Now if you integrate this one, we're having x here. So we have x, so this dx goes away. So from this point now, what do we need know to do? This and this is 6. So I will have 6x raised to the power of 6 over 6. That's what I'm having here. This is 6. So 6 is x raised to the power of 6 over this 6. Then we have this. Now plus here, same as this. This is 3 here. So 3x squared over 3 minus here is 8x. This is 4. 4 here over 4. Then plus just 10x. That's all. This one, you know, this one is a constant. So you just add x to it and that is all. You're not doing anything to it till the answer. Just add x to it and that is all. Remember, I said anywhere you start integrating, you add plus c. So yeah, I'm supposed to add plus c here. So observe that this is common here. I can do it like this. This one can take care of this. I can do it like this. This can take care of this. I can do this like this. Then plus 10x will give us c. This becomes how this is done here. This is how you do this one. Number 2, if I have the integration of this value with respect to x, dx, sorry, respect to ds. So first thing, what do we know? We are to expand this, expand it. That's the first thing. So let's expand this 2 first. That means I'm using this one and this 2 bracket. That's what I'm using first, leaving this one first. So this 3x to multiply this 2. So 3x times x here, I'm going to have that here becomes 3x squared. 3x times this one here will give us 6x here. That's what I'm having. Now, next up here now, I will now take this one to multiply these 2. So I'm having x here and then 2 here. That's 1 times x is x, 1 times 2 is 2. So I have this. Next up, I still have this one here. So I'm going to use this x now to multiply all of this one and then use minus 1 to multiply all of this one. So I will start from here. X times all of this one. Now here, I'm having here to be 3. This is power 1. X here is 1. So 1 plus this one, that will give us 3. So here, this is 1, this is 1. That will give us 6x squared. Here, this is x squared. Here, this is 2x. Now, minus 1 to multiply everything. If minus 1 multiply everything, we're having this value, minus 6x, minus x, minus 2. So this is what I'm having here. Now, what's the next thing we are going to, we have not started integrating. So let's check the highest power here. The highest power of x here is 3. That's the highest power of x. So bring that out. And that highest power is only appearing once. There is no there's no x cube again here. So next, let's go to x squared. This is having x squared, and x squared. So this is 1 here. So this one plus this one, that will give us 7x squared. Minus this one, that will give us plus 4x squared. That's what I'm having here. Now next up here, so I'm having the ones without x, this one, and this one without x. So this minus this one, that will give us minus 4. Minus 4 minus this is 1. That will give us minus 5. So I'm having minus 5x, then minus 2 here. So here, I'm now going to separate them. So I have this value, cube dx here, plus the integral of this value, dx there, and then the integral of 5x here, now dx here. Please always add your dx. So now minus the integral of 2 dx. So that's what I have. So next up now, take out the coefficient. So I have this one here. So x cubed dx here, plus take it out, x cubed dx square. This is the x square, please. So minus 5 out. So I'll have the x here minus 2. This is the x, or 1 dx as the case will be. So from this point now, I can start integrating now. So if you are integrating, this and this goes off, the integral and this one goes off. So I have 3 plus 1. So whatever you are having as the power, only the power, please. Don't repeat the x, only the power. So 4 into bracket, this is 2 plus 1. Only the power, please. Only the power. So this one becomes 1 plus 1. So 1 plus 1 here. Then minus 2. So here, I'm just putting x. Remember from the beginning, watch this. We have 2 here. So there's no x with it. So that's a constant. So just add x to that. So if you add x to this one, that is all. You're not integrating that as 1 plus 1. You just leave it as x. Because 2 there doesn't have x from the beginning. Look at it. There's no x with it. So from here now, what do we know to do? This will give us 4. So I'll have 3x raised to the power of 4. That is this one times this x raised to the power of 4 all over 4 here. Then plus this is 3 times this one. That will give us 4x raised to the power of 3 over 3 minus this one. That will give us 5x squared over 2. Then this will give us 2x. So I told you, wherever you integrate, you put your x squared. This is it. This is how you do this one. It's so very, very simple. Please do well to subscribe, share this video, comment, and then tell people about this channel. So this is how you do the question. We're asked to do the integral of x plus 1 x dx. This is what I have here. First thing, because I have plus here, I'm going to separate the integral sign. I have the x here plus the integral sign. I have the x here. Next up is there is no coefficient here. So for this one, if I want to integrate this one, I'm having 1 plus 1. So remember that this and this goes away. The integral sign and the x goes away. I have this. Now, plus, remember what we said. We say 1 over x is ln this one. So I'm going to put 1 like this. This is what I'm going to put here. So if you 1 over x, will give you that. So here, I'm going to have 2 over 2. So because I've integrated, I'll put this, then 1 over x, then plus c. This is how this is done. It's very simple. This is how this is done. 4. So we're asked to find the integral of this value, 2x plus 5 over x. I want to do this one. So from here, what do we do? First off, we are going to, this x is to divide all of this one first. So have this one. So we have cube over x here, then minus 3x squared over x here, plus 2x over x here, and then 5 over x here. That's the next thing. So next, remember, we're having the x here, please. Don't forget that. So this becomes our dx. So because of the sign, different sign now, we're going to integrate this now. So I'm having this. Okay, let's just cancel this one. This is square here. So I have the x here. So this can cancel this. So I'll have 3x because this is 2. So 1 dividing 2, we're having 1 of the x left here. Then I have the x here. Then plus here. This can cancel this. See now, this becomes just only 2. So the x here. Plus here, I'll have 5 over this value now. So I have the x with it. So this is what I have here. Now from this point going, so I already know that if you go forward, this does not have a coefficient, so we can start integrating this one. So this value becomes 2 plus 1 over 2 plus 1. I told you that the dx and this value goes away. So this is having 3 here. So we can still differentiate this one, which is x 1 plus 1 over 1 plus 1 here. Here, bring the 2 out. So remember that this is just 2. If you are integrating, you add x to that. So when you add x, that is all. You're not integrating it again. So this becomes x. Because we have cancelled this x here. So this becomes constant here. Just integrate that. So plus here, bring the 5 out. We are now going to have 1 over x. And I told you what we are doing if you have 1 over x there. So from this point now, what do we know? So we said that x will give us is to the power of 3 here and 3 here minus this is 2. X is to the power of 2 and this one. So this will give us 3x raised to the power of 2 over 2 here. Then plus here will give us 2x here. Then plus 5. So this becomes the natural log of x. Then we're adding plus c here. That is how this is done. So this is how it's done. It's very simple. It's a very simple, straight and direct thing. So number 5 here, we're asked to do this. So the x, 3 root x squared. I want to do this. First thing is first. Look at this question. Hope you know that if I have a over 2, I can also write it as a times 1 over 2. They are the same thing. Yes, so 1 times a gives you a back over 2. So here, this is the first thing I'm going to do here. I'm going to have that here becomes 1 all over 3 root x squared. Then I'll have the x here. So 1 times dx will give us dx back. So from here now, we're going to have that here will give us, when you remove this root first, you're going to have that 1 all over. So that will give us x squared all raised to the power of 1 over 3. So don't forget that the x indices, when this is root 3, when you take it back, originally you're going to have 1 over root 3 there. So what do we know to do here? I'll apply indices first. When I multiply this will give us 2. So if I apply indices now, in indices, if I have this, I can change it to a raised to the power of 1. It's only working for 1 alone. It's only working for 1 alone. If there is 2, you cannot do this thing. So if you want to do it, it is simple, but for 1 alone, first, that's what I'm talking about, for 1 alone. So if I have 1 over b, if I want to change this one, I can change it like this. Yes, I'm correct. So here, I will now have that the integral of x minus 2 over 3. So this minus is coming from this one. Look at it here. That will give us that. So all this one will give us the x here. So from this part now, so if you integrate this one, we have this over this plus 1, please. So whatever you do, the power, not the x this time around, just the power, write it down here. So because I've started integrating, I'll put this. So here I'll find my LCM here. So that will give us, my LCM is 3. 3 and 3 is 1. 1 times this will give us minus 2 here. Then what do I know? Then here will give us plus 1 and 3 is 3. 3 times 1 will give us 3. So all over, same thing. If you find the LCM, same thing. We're going to have 3 minus 2 plus 3. So here I have that x here will give us 1 over 2 here. All over here will give us 1 over 3. This is how 1 over 3, please. This is how this is done. So plus c. Don't forget, you must always try and learn to put your plus c, because if you don't put